The easiest thing to do to work out the equation of the line is use the formula y minus b equals m bracket x minus a. This is the gradient here, and this is the point AB. So y minus 5 equals minus 3 bracket x minus minus 2, y minus 5 equals minus 3 bracket x plus 2. If we expand the bracket here, minus 3x minus 6, and add 5 to both sides. And the final answer then is y equals minus 3x minus 1. Nice simple inequation to solve. The first thing we should do is gather together the letter terms. So I'm going to subtract p from both sides. 3p minus 12 is less than 6. Add 12 to both sides. 3p is less than 18. And then divide by 3. P is less than 18 divided by 3 is 6. It's a nice simple question. We have 3 adults and 2 children, and it costs £32.25. Write an equation to represent this information. 3 adults plus 2 children equals 32.25. Nothing more is required. Solve the pair of equations. What I'm going to do is to label the equations 1 and 2. I'm going to choose to eliminate b, so I'm going to multiply equation 2 by 5, and that gives me 5a minus 5b. 5 times minus 3 is minus 15. And I'll write equation 1 underneath. And I hope you can see that by adding the two equations, we get 8a equals 39 take away 15 is 24. A then is 3, and we substitute that back into equation 1 to find the value of b. So 3 lots of a, 3 lots of 3, plus 5b equals 39. 9 plus 5b equals 39. Subtract 9 from both sides, 5b equals 30, and divide by 5, b equals 6. Change the subject of the formula to x. So the first thing I'm going to do is to subtract 6 from both sides. So s take away 6 equals 2x over 3. The next thing I'm going to do is to multiply both sides by 3, and I'm going to put a bracket round this term here, or both terms rather. The last thing I'm going to do is to divide by 2, and I'll turn the equation round, so x equals 3 times s minus 6, all divided by 2. X is now the subject. I want to work out the value of k, so I'm going to pick one point on the graph. I'm going to pick this point here. That point has coordinates 2 along and 20 up. So 220. The x value is 2, the y value is 20. I'm going to substitute those values in here. So y equals kx squared. 20 equals k times 2 squared. 20 equals k times 4. What do you multiply by 4 to get 20? Well, if we divide by 4, we get the value k equals 5. And the equation, although we're not asked for that, is y equals 5x squared. Now the important value on the graph is this value here. That's the turning point, and that has coordinates 1 along and 2 up. Now, if I have the coordinates of the turning point, I can form the equation very quickly. It's x minus 1 in this case, all squared, plus 2. Remember, if we have a minus 1 in the bracket, it means the graph has been moved one space to the right. So if I compare the equation I've just formed with the one given, I hope you can see that A has the value minus 1 and that B has the value 2. Now, y equals x minus 1, x plus 3. If I set this equal to 0, I can find the x-intercepts. So x minus 1 equals 0, x plus 3 equals 0, x equals 1, and x equals minus 3. So the x-intercepts then are 1, 0, and minus 3, 0. To get the y-intercept, I'll set x equal to 0. So if we go to this equation here, replace x with the value 0, it's y equals 0 minus 1, 0 plus 3, 0 minus 1 is minus 1, 0 plus 3 is 3, so it's minus 1 times 3 is minus 3. So the y-intercept is at 0, minus 3. The axis of symmetry. The axis of symmetry is found halfway between the two roots, these values here. So what we'll do is, we'll add those two values together, 1 plus minus 3, and divide by 2. Minus 2 over 2 is minus 1. Now I want to work out the y value of the axis of symmetry, so I'm going to substitute this value minus 1 into this equation here. So y equals minus 1 times minus 1 plus 3, and that's minus 2 times 2, and that is minus 4. What does this give us? Well, if we expand, let's just say we expand the two brackets, these brackets here, we have x squared plus 3x minus 1x minus 3. Now the reason I'm doing that, although we didn't need to, was to show you that what we have here is a positive x squared, which is to say we have a graph that looks like so. So this point that I've just worked out, minus 1, minus 4, are the coordinates of the minimum turning point. Now, I'm going to make a very rough sketch here. Doesn't need to be anything fancy. So I know that one of the roots is minus 3, and that one of them is 1, and that we've got a happy face. There we are. This is the point minus 3 here, the y-intercept. Here is the axis of symmetry. And this point here, which is the minimum turning point, has coordinates minus 1, minus 4. And I suppose we should just label the axes x and y. So, write down the equation. Well, what we're going to do first of all, in fact, I'm going to do part B first of all. Part B is nice and simple. The coordinates of the turning point. So, we have a minus 3 in the bracket, which means that the graph has been shifted 3 spaces right. So the x coordinate of the turning point is plus 3, and the y coordinate is 4. Now, this here is a positive x squared, which means we've got a happy face, which means that the point 3, 4 is a minimum turning point. Part A, the axis of symmetry, here it is here, x equals 3. Nice simple equation, already done this sort of thing earlier on in the test. So x minus 3 equals 0, x plus 7 equals 0, x equals 3, and x equals minus 7. Nothing else is required. The key to this problem is this phrase here, 1 decimal place. That means we're using the quadratic formula. So here is the quadratic formula. Let's look at the equation. A, which is the coefficient of x squared, is 1. B, the coefficient of x is 2. And C, the constant term, is minus 7. B squared is 2 squared, which is 4. 4ac is 4 times 1 times minus 7, which is minus 28. And b squared minus 4ac is 4 minus 28, which is 4 plus 28, and that's 32. So, minus b, minus 2, plus and minus the square root of 32 all over 2 times a, 2 times 1, minus 2 minus root 32 over 2, and minus 2 plus root 32 all over 2. And that gives minus 3.8284 and 1.8284. We want the answers rounded to 1 decimal place. That's minus 3.8 and 1.8. So A has the value 3, B has the value 2, and C has the value minus 1. B squared is 2 squared, which is 4. 4ac is 4 times 3 times minus 1, and that's minus 12. B squared minus 4ac is 4 minus 12, and that equals 16. Since b squared minus 4ac is greater than 0, there are two real distinct roots. Converse of Pythagoras' theorem, so what I'm going to do is to work out ac squared. That's 6.3 squared, which equals 39.69. Then I'm going to work out ab squared plus bc squared, the sum of the squares on the shorter two sides. So that's 5.4 squared plus 3.3 squared, and that equals 40.05. Now, since ac squared does not equal ab squared plus bc squared, by the converse of Pythagoras, the triangle is not right angled. That's the first part. And the second thing you could say then is that the mast does not make a right angle. That's you answering in context. Question 14. What we have is a tangent kite, which means this angle here is 90 degrees, and this angle here is 90 degrees. So if I want to work out this angle, I'm going to add 90 plus 90 plus 126. So that's 180 plus 126 is 306 degrees. So the missing angle x is 360. The angle's in a quadrilateral, take away 306, and that gives us 54 degrees. So we've got two cylinders. I'm just going to draw them as rectangles. Imagine those as three-dimensional shapes. The shape, so one is 15 centimetres long and the other is 150 centimetres long. The volume of water in the container is 12,000 centimetres cubed, so this volume is 12,000 cm cubed. So the length scale factor, reduction, final over initial. So it's the final, if it's reduction then we're going from the larger to the smaller. So it's 15 over 150, which is 1 over 10. Now the volume scale factor, reduction, is the length scale factor cubed. So it's 1 over 10 cubed. 10 times 10 times 10 is 1,000, and that's 1 over 1,000. Now what that means is that this volume here is 1 over 1,000 times this volume. So the smaller volume, the new volume, is 1 over 1,000 times 12,000, and that gives us 12 cm cubed. Regular 5-sided polygon, what I'm going to do is to work out this angle here, and that's 360 divided by 1, 2, 3, 4, 5. So 360 divided by 5 is 72 degrees. Now the fact that it's a regular shape means that this side and this side are the same, so this angle is the same as this angle here. So what I want to do then is to subtract, so y, it's 180, the angle's in a triangle, take away 72 divided by 2, so that's 108 degrees divided by 2 is 54, and this shaded angle here, the shaded angle is 2 lots of y. If you just imagine a dotted line here, so this is y as well. So it's 54 degrees times 2, and that's 108 degrees. So the graph of 4 sine x has a maximum value of 4 and a minimum value of minus 4. We want to draw the graph between 0 and 360 degrees. So here are the 4 important values on the x-axis. And I'm going to mark 4 and minus 4 on the y-axis. Sine starts at 0 and goes up to its maximum, down to 0, down to its minimum, back to 0. And that's the graph of y equals 4 sine x. So the period of this function, well, it's the cosine. Now the period of the cosine function is normally 360 degrees, but this one has a 3 here. That means there are 3 cycles between 0 and 360 degrees, and that each cycle then lasts for 120 degrees. We'll add on to both sides, and that gives 4 sine x equals 1, divide by 4, sine x equals 1/4. Cast diagram. The sine function is positive in the first quadrant and the second quadrant. So calculators, x equals sine to the minus 1 of 1/4, and that equals 14.5 degrees. And the second value is found by subtracting 14.5 degrees from 180 degrees, and that gives us 165.5 degrees.